This is drawing ray diagrams for thin lenses. What we're showing here, I'll just kind of label it and erase this. I don't know if I would write this down. I guess you could. This is what we call the object. It's some object in front of you. It could be anything, but typically something that's luminous. So light bulb, okay? Could be a person if there's a lot of light shining off of them. This is a thin lens. It's a convex, biconvex lens. That means it's curved on this side, it's curved on this side, but it's very thin. Excuse me. What we're going to do is we're going to draw rays of light going from the object through the lens and producing an image on this side. This is what your eye does. This is what a magnifying glass can do. This is what a telescope does, a refractive telescope. So these are called focal points. A focal point, and there's also another focal point. This is the near focal point. That's the far focal point. In fact, do we need this one? We actually don't need that one. Today, for light, let's use green. And here are the things you need to know, and I'll make this video pretty short. We start at the top of the object. You draw a line of light, a ray of light that shines to the lens. And what this lens is going to do is it's going to bend the light. And so let's do that already. Before we get started, draw a dotted line. I'm going to use black. Draw a dotted line in the middle of your lens. I should have added that to the diagram, but that's okay. So let's draw a ray of light that goes parallel, not dotted, that goes parallel. I'll give you that terminology. Draw it straight across, parallel, parallel with this dotted line here. Um, we call that I think it's called the optical axis. It's basically where the bottom of the object is. Draw a ray of light that goes straight to the lens, parallel with the dotted line. So if you're using a ruler, you just kind of try to make sure that that's straight. In other words, you don't want a line that goes like this. That's not parallel. This line is not parallel. That is parallel with that dotted line. That ray of light doesn't just stop there. It bends through the lens through refraction. And we know where it bends through. We know it's going to go through the far focal point and go all the way to the edge of the page, as far as you can go there. This is what we call the first ray of light, the first ray that we're using to figure out where the image can be found. The second ray of light is not going to go parallel. It's going to go through the middle, the center of the lens where it hits that optical axis. I think that's what it's called. That axis that's there. But this time, even though it does bend, you won't notice it. And so here I'm going to draw my line. Oops, not like that. I want to go straight through. See if this will work. No, this will not work. Okay, it's going to be a little bit bendy here. Look, let's just go here. It's not doing it. How about from here to here? How strange. I'm going to play a little trick here. Let's see if this works. Sorry for this. It's not quite. I'm going to try this one more time. And let me not let it snap. I think I'm just going to draw it. It'll be free-handed. I don't like freehanding it. Thank you for bearing with me. Yeah, it's going to keep doing that. Okay, let me think. I know what I'll do. I know what I'll do. I'm going to go ahead in this video show you 3 rays of light that you can draw. So what we're going to do is actually going to go through the near focus and it's going to go to the lens. So let's see if that works. And of course it does. Weird. So the third ray of light we could draw, I'm skipping the second one because I'm just having trouble here with my drawing. The third one actually goes to the near focus and it goes to the lens, but then it will go parallel with the dotted line about right there. Cool. And so right here where these two lines intersect, that is where the image is located. Now, the top of the object will be where those two lines, where the image from, okay, the top of this object is where the top of the image will be. And in fact, this will be an upside down arrow. So the bottom is still on the axis, the optical axis. I'm going to look that up. I keep saying it and I want to know if it's right. Yeah, that's what it's called. The optical axis. Cool. Second, okay, let's go back. The second ray is one that should go from here through the center and also intersect with those. So I'm going to try it one more time. And if it doesn't work, well, we're just going to have to use our imaginations. So okay, that actually worked. This is the first ray, this was the second ray, and this was the third ray. That's not too important. On your quiz, on your assignment, all I need to see are the first two rays. You don't need to draw the third ray. So, and on this side, this was the first ray, this was the second ray, and this was the third ray. Okay, cool. So this is the image. Must know that that is the image produced. Notice that it is not as tall as the object, so we say that it is a reduced image. That means it's literally smaller in size. Notice that it is upside down, so this is an inverted image as opposed to upright. Reduced as opposed to enlarged. And the last thing we can note about this is, oh, yes, yes, yes. These are real rays of light that are making this image. You don't know what a virtual image is, but for now, we'll just say it's a real image. If I took a magnifying glass and I have like a light source like a light bulb, and I put the magnifying glass at just the right spot and a screen at just the right spot here to collect the image, it's real rays of light that are making the image. Cool, and that's what you have to do on a quiz. Be able to draw the first two rays, and I'm not sure yet if you're going to have to do all of these, but you should know how to write these. Probably not real, but you should be able to tell me if it's reduced or inverted. One of those or both on a quiz. And you should draw the image. A lot of people draw the rays and they don't draw the image there. You have to draw it. Well, let's try another one. Still have time. Still have time. Okay, I'm using green. That's okay. Let's draw red rays of light this time. I'm going to start from the top of the object. So right there. We'll draw our first ray parallel with the optical axis. Whoops. It will bend through the lens, and we know where it bends. It bends through the far focus, far focal point. Goes there. Now, am I going to be lucky? Am I going to be able to get the second ray by itself? It's going to go through the center of the lens. A lot of people mess up and they go like this. Not right. Or what else did they do? Um, yeah, they do something like that. Let's just go through the center of the lens and it keeps going. In reality, it will bend. That's perfect. That's good. In reality, the light does bend here, but from the way we're looking at it right now, you don't really notice, and we can kind of just ignore that and just keep drawing it. And so first ray, second ray. Where the two intersect is the top of your image. The image is a circle, And on mine, I can draw a perfect circle here, something like that. Although I need to move it over a little bit. Okay. Notice that this image is not reduced, it is actually enlarged. Enlarged. You can't tell, but it is inverted. So maybe on your quiz, I'll make sure it's an arrow or something that can be inverted. You can't tell it's inverted, but it is inverted. And the way you know that is because of the position of the optical axis. The object was above the optical axis. Here it is below the optical axis, so it's upside down. If you drew a face on it, and it would look like this. Cool. So on a quiz, let's use purple. You would get a point for drawing the first ray correctly. It goes straight parallel, and then goes through the far focus. It's got to be perfect, and it's got to have an arrow on it. It's a ray of light, and that's how we draw 'em. The second ray goes from here to the center of the lens, all the way to the edge of the page. Does not bend at all. It just goes straight through. You drew that one correctly. That's a point. You drew an image where those two lines intersect is the top of the image, and the bottom of the image is on the optical axis. That's got to be drawn correctly. And yeah, I think on your quiz, I will tell you to let me know it's enlarged or reduced, if it is reduced. And you tell me if it's inverted or if it's upright. It's probably going to be inverted. Cool. Let's do another one. Notice that the object is placed at the the near focal point. And so something, this one will be unique, or it'll be different from the other ones anyway. Let's draw two rays of light. I'll use, oh, I don't know, pink. And we'll use brown. First ray, parallel. Bends through that focal point, just about to the edge of the page. It will go through that one there, goes through the, what do you call it? The center of the lens, does not really bend. So you will notice now with this one, those are our two rays that are drawn correctly, that they don't meet like this one. And I'm just doing this on my, doing this here by hand. They look parallel, but they're not perfectly parallel. If we did this perfectly, it would be perfectly parallel. And so these two rays never meet. No image is produced. So I'm not going to give you that on a quiz because there's not really a way to grade that very well. But for objects that are placed on the focal point there, it does not produce an image. I think for the video, I'll just stop with this last one. What if we take an object and place it between the lens and the focal point? That's interesting. I think what I'll do is I'll draw in here in the middle. It just helps. Let's draw a line parallel, goes through the far focal point. That's your first ray. The second ray will go through just like that. Whoops. Let's do that again. Wanted to draw it better. There we go. Cool. These, again, don't meet, and so you would think there's no image, but they're not parallel. And what we can do is kind of like a little trick. We can actually move backwards. So we can follow this backwards. Okay, let me try this. I'm going to start my dot right here. I'm going to go back this way. I'm going to try to match those up. There we go. And normally we do that with the dotted line. So let me be true for the notes. There's a reason why we use a dotted line for this. And match it up. And start here. And let me match that one up. There we go. So we can produce an image, but you notice we had to use this trick where we trace the lines backward. Where those two lines meet will be an image. Never draw this one super perfect, but okay, that's my star. I did it in a dotted line. You don't have to do that, but these rays, the purple rays, you do want to draw those in a dotted line. Because we had to trace them back, we call this virtual. If your eye is on this side of the lens, whoops, come on. If your eye is on this side of the lens, oh, that's not how I draw it. This is kind of how I draw it, I think. Something like that. If your eye is on this side of the lens, looking through the lens here, you see a enlarged or magnified image, and we call this a virtual image. This is enlarged. It is, uh, first of all, it is upright. Notice that the bottom of it is on the optical axis, the top of it is above the optical axis. This is not inverted, and this is a virtual image. Virtual means that these are real. This right here is a real ray. The dotted part going back here, this is a virtual ray. It's not a real ray, but our eye is fooled into thinking that this ray of light and this ray of light just continue on straight backward, and that the object is not here, but it is actually here. So it's like an optical illusion, let's say. But yeah, in physics we call that a virtual image. Cool. And I realized that we forgot to say this is a real image over here, but I probably won't ask you for that on a quiz, but maybe a test. Okay. And I'll stop here. This is for on level, so yeah, I would say this is called a diverging lens. Um, I could show you this in class if you really want to see how that one works. I'll keep this video short.